Healthcare provider. Annual DR test. First one ever actually scheduled, not just documented. Saturday morning. The plan says, quote, restore the patient records database from offsite backup tape, end quote. The team pulls the tape, sticks it in the drive, kicks off the restore. It fails. They try a different tape. It fails. They try the third tape. It fails. By lunchtime, they have walked through 6 tapes from 3 different weeks, and not one of them is readable. Turns out the backup job had been silently writing corrupted data for 14 months. The verification step had been disabled by somebody at some point for some reason, and nobody noticed because nobody had ever tried to actually restore. 14 months of backups, none of them usable. The lesson: a backup that has never been tested is not a backup. It is a hope. Today we make sure your hopes have been verified at least quarterly. Objective 3.4, Resilience and Recovery. Let's go. Start with high availability. HA means designing systems so that no single point of failure takes the whole thing down. Single point of failure, SPOF, is the term, and finding them is the job. Load balancing distributes traffic across multiple servers. 2 modes you must know. Active. Every node serves live traffic at the same time. If one fails, the others absorb the load. Better performance because you are using all the capacity. Faster failover because the surviving nodes are already warm. Active-passive. One node active, one or more on standby. Standby promotes when primary fails. Simpler logic but expensive because the standby capacity sits idle. Most modern designs default to active when the application can handle distributed state. Clustering. Multiple servers share a workload and shared state presented as a single logical system. Automatic failover. One node dies, another picks up without a human touching anything. SQL always on, Oracle RAC, application server clusters, vSphere HA. Clustering is what makes a database survive a node loss without a 30-minute restore window. You want clustering when the recovery time tolerance is in seconds, not hours. Recovery sites. 3 classic types, 4 if you count cloud. Hot site, fully operational duplicate. Live data replication, systems powered on, ready to take traffic now. Time to operational, minutes to hours. Cost, the highest, because you are paying for a fully redundant data center that mostly sits idle. Use it when RTO is measured in minutes. Warm site, partially configured. Hardware is racked, some data is present, systems may be powered down. Time to operational, hours to days. Cost, medium. Use it when you can tolerate a business day or 2 of downtime. Cold site, empty facility with power and connectivity. No hardware, no data. Time to operational, days to weeks. Cost, the cheapest. Use it when RTO is measured in weeks and the cost of a hot or warm site cannot be justified. Cold sites are paper plans most of the time, and paper plans are the most likely to fail when you actually need them. There is also the cloud variant, a recovery site provisioned on demand from a cloud region using infrastructure as code. Sits between warm and hot in cost depending on how much you preload. One rule that applies to all of them: geographic dispersion. The recovery site must be far enough away from the primary that the same regional disaster does not take both out. A primary site in downtown Houston with a recovery site in suburban Houston is not geographically dispersed. A hurricane takes both. Distance is measured against the threats you actually face: earthquake fault, floodplain, power grid, tornado alley. Pick the recovery region for resilience, not for proximity. Platform diversity. Use different operating systems, different hardware vendors, different software versions across the infrastructure. Reason: if every server runs the same OS build, 1 zero-day takes them all. Diversity reduces the blast radius of a single vulnerability. The trade-off is operational complexity. 2 operating systems mean 2 patching pipelines, 2 hardening guides, 2 monitoring stacks. Most organizations land somewhere in the middle. Diverse where the threat justifies it, homogeneous where the operational cost would crush the team. Multi-cloud strategy. Workloads across AWS, Azure, GCP, sometimes more. Benefits: no vendor lock-in, no single provider outage, takes everything down, can pull best-of-breed services from each. Challenges: consistent security policy across providers, identity federation that actually works, cost management because every provider charges differently, and monitoring that aggregates across vendors. Multi-cloud sounds great in a strategy slide and is a discipline in practice. Start with one provider, do it well, then add the second deliberately. COOP, continuity of operations, a formal plan for keeping critical business functions running during and after a disruption. Identifies essential functions, the people who run them, the resources they need, and the alternate facilities they use. COOP aligns with BCP, Business Continuity Plan, the broader plan for maintaining operations. DRP, Disaster Recovery Plan, is the technical subset focused specifically on restoring IT systems. The plain English mapping, COOP is the government term, BCP is the corporate term, DRP is the technical IT restoration plan that lives inside both. Capacity planning. 3 dimensions. People, enough trained staff to actually run the recovery, cross-training, so a single person being on vacation is not the failure point. Vendor support contracts in place before you need them. Anyone who has ever sized the load balancer at 3 a.m. during an outage knows what missing people capacity looks like. Technology, compute, RAM, storage growth, database scaling, bandwidth, headroom, infrastructure, power capacity, UPS, generators, PDUs, cooling, physical rack space, network bandwidth. The peak load case during disaster recovery is the trap. Backup operations run at the same time as normal workloads, and many environments cannot sustain both. Resilience testing. 4 methods, ranked by realism. Tabletop exercise. Discussion-based walkthrough. Stakeholders sit in a room and talk through their responses to a scenario. No systems involved, no risk to production. Cheapest, easiest, the right starting point. Failover test. Actually trigger the failover to the secondary system. Production or controlled test environment. Most valuable because it verifies that the recovery actually works end-to-end. Documentation only DR plans fail in real disasters at a rate that should embarrass everybody who signs them. Simulation. Realistic disaster scenario that may involve real system actions in a controlled test environment. More realistic than tabletop, less risky than a full production failover. Parallel processing. Run both primary and backup systems simultaneously and compare outputs for accuracy. Useful for migration testing as well as DR verification. Recovery plans must be tested regularly. A plan that has never been tested is not a plan, it is documentation. Backups. 3 types you absolutely must know cold for the exam. Full backup, everything. Slowest to create, fastest to restore, because the restore needs only one set. Incremental backup, changes since the last backup, full or incremental. Fastest to create, slowest to restore, because the restore needs the last full plus every incremental since. If any link in that chain is damaged, the chain breaks. Differential backup, changes since the last full backup. Medium speed to create, medium speed to restore. Restore needs the last full plus the latest differential, 2 sets total. Differentials grow each day until the next full because they always reach back to that full. Most organizations use a combination. Full weekly plus incremental daily is the classic small shop pattern. Full weekly plus differential daily is faster to restore, but consumes more space toward the end of the week. The trade-off is storage cost versus restore time. Pick the one that matches your RPO and your RTO. Backup best practices. The big rule the exam treats as gospel. 3-2-1. 3 copies of the data. 2 different media types, disk and tape or disk and cloud. 1 offsite, geographically separated from the primary. Memorize that. 3 copies, 2 media, 1 offsite. Backup encryption is mandatory. A stolen, unencrypted backup tape is a reportable data breach. Offsite storage means truly offsite, not the closet down the hall. Immutable backups, backups that cannot be modified or deleted within a retention window. This is the ransomware control. If your attacker can encrypt your backups along with your production, the backups did not protect you. Immutability, write once, read many, hardware enforced or vendor enforced retention locks, breaks that attack pattern. Test restores periodically. Once a quarter, pull a random backup, restore it to a sandbox, verify integrity. The cold open story does not happen if the test restore happens monthly. Backup frequency is set by RPO. If RPO is 4 hours, backups run every 4 hours. If RPO is 15 minutes, you are not running backups, you are running replication. Snapshots. Point-in-time copies of a volume, VM, or database. Created quickly using copy-on-write metadata. Minimal initial storage. Common in VMware, AWS EBS, Azure Managed Disks, every modern database. Critical caveat. Snapshots are not backups. A snapshot lives on the same storage system as the original. If the storage system fails, you lose both. Use snapshots for fast rollback and short-term recovery. Use real backups for the storage failure case. Replication. 2 modes. Synchronous replication. The write is confirmed only after the data is committed to both the primary and the replica. RPO of 0. Used for financial systems and other zero data loss workloads. The cost is write latency. Every write waits for 2 acknowledgements. Asynchronous replication. The write is confirmed at the primary, the replica gets updated shortly after. Near zero RPO, much lower latency impact, small data loss window if the primary dies before the replica catches up. Replication gives you geographic redundancy and rapid failover. It does not protect against logical corruption. If you delete a record on the primary, the deletion replicates too. For corruption protection, use point-in-time snapshots or backups. Journaling. The system maintains a log of all changes to a file system or database. After a crash, the log is replayed to recover to a known consistent state. File system journaling, X4 on Linux, NTFS on Windows, is what keeps your file system intact after an unclean shutdown. Database transaction logs allow roll forward to a specific point in time or rollback of an in-flight transaction. Journaling is the layer below backups that keeps the system internally consistent. One reality the exam dances around but operators live with daily. Ransomware changes recovery math. The classic 3-2-1 rule was written for fires, floods, and hardware failure. Modern ransomware operators specifically hunt for backup infrastructure before they trigger encryption. They sit in your network for weeks, find the backup server, find the snapshot console, harvest credentials for the cloud backup target, and only then do they pull the trigger. If your backup admin credentials use the same single sign-on as your laptop, your backups are compromised the same minute your laptop is. 3 controls fix this. 1. Separate identity for the backup infrastructure, not federated to the production identity provider. 2. Immutable retention on the backup target, hardware or vendor enforced, where even an admin cannot shorten the retention. 3. Offline copies. A tape that physically left the building yesterday cannot be encrypted today. The 3-2-1 rule is still right, it just means more in 2026 than it did in 1998. Power resilience. The pieces. UPS, uninterruptible power supply. Battery-backed power provides clean power and brief runtime during an outage, typically 10 to 30 minutes, long enough for a graceful shutdown or for the generator to come online. Generator, fuel-based power for extended outages. Hours to days depending on fuel supply and refueling logistics. The standard data center combination is UPS plus generator. The UPS covers the gap, typically 10 to 30 seconds, while the generator starts and reaches stable output. Dual power supply, 2 independent feeds to the same device, each from a different circuit, ideally a different PDU on a different UPS on a different generator. One feed can fail without affecting the device. PDU, Power Distribution Unit, the smart power strip in the rack, providing remote monitoring, metering, and per-outlet control. Servers, switches, and storage arrays should all have redundant power supplies fed from different PDUs. If the rack only has one PDU, the rack is the single point of failure. Now the 4 metrics that the exam absolutely will test. RTO, Recovery Time Objective. Maximum acceptable downtime after a disaster before business impact becomes unacceptable. Set by the business, not by IT. RPO, Recovery Point Objective. Maximum acceptable data loss measured in time. How old can the restored data be? Also set by the business. MTTR, Mean Time to Repair. Average time to restore a failed component to full operation, measured by IT and operations, MTBF, mean time between failures. Average time between failures, a measure of reliability, also measured by IT and operations, plain English mnemonic. RTO is how long you can be down. RPO is how much data you can afford to lose. MTBF is how often does it break. MTTR is how long does it take to fix. RTO drives the recovery site decision. RTO of minutes means hot site or active HA. RTO of hours means warm site is acceptable. RTO of days means a cold site might be sufficient. RPO drives backup frequency and replication strategy. RPO of 0 means synchronous replication. RPO of 1 hour means backups or async replication every hour at minimum. Lower RTO and lower RPO always cost more. The business has to choose where the money goes. Action checklist. 1. Find your single points of failure and remove them. Load balancers, clusters, redundant components. 2. Pick the recovery site type that matches your RTO. Hot site for minutes, warm for hours, cold for days. 3. Geographically disperse your recovery site against the actual threats you face. Same metro is not enough for hurricanes, earthquakes, or grid failures. 4. Backups follow the 3-2-1 rule. 3 copies, 2 media types, 1 offsite. Memorize this, the exam will ask. 5. Encrypt every backup. Stolen unencrypted backup equals reportable breach. 6. Keep backups immutable for the ransomware case. The attacker should not be able to delete your only path home. 7. Test restores quarterly minimum. A backup nobody has tested is not a backup. 8. Full backup is slowest to create and fastest to restore. Incremental is fastest to create and slowest to restore. Differential sits in the middle and only needs the last full plus the latest differential. 9. Snapshots are not backups. They live on the same storage. 10. Synchronous replication for 0 RPO at the cost of write latency. Async replication for near 0 RPO with less latency cost and a small loss window. 11. UPS covers the generator startup gap. Together they keep the lights on. Servers need dual power supplies fed from different PDUs. 12. RTO drives site choice. RPO drives backup and replication frequency. MTBF is reliability. MTTR is repair speed. Know all 4 cold. That closes domain 3. Architecture, infrastructure, data, and resilience all stacked into one body of work. Next up, domain 4. Security operations. Objective 4.1 picks up with applying common security techniques to computing resources. Hardening targets. Baseline configurations, secure deployment patterns. We move from designing the architecture to running it day to day. See you in 4.1.